I'm curious.
I don't know. We'll learn more in this panel. So upcoming, we have Neylz with their panel Core Shaders, the Unsupported Feature Unlocking the VFX World. I know this is one of the more exciting ones because it's very visually stunning, and Neylz has worked really hard to put together a really cool showcase. So in just a minute, you can join Discord stage or in-game or the live stream. Now, by the nature of shaders, not everybody will be able to have the most supported experience just because it's kind of difficult to make a shader that works on every GPU. But it should work for most people. If you ever feel like it doesn't work for you, you can always check out the YouTube stream, and we've confirmed that the YouTube stream has what is expected or like what is supposed to be seen. So that is always an option. But other than that, we might be ready to go. So everybody welcome Neylz to the Core Shader panel, and we can go ahead and get started. Thank you.
Great. Hello everyone. I see there is a lot of people. So that's a bit okay. I'm going to give you all a spyglass, so it will be useful for later during the panel, or even now if you want to watch the slides directly. I'm going to start with that. Like, who has ever touched shaders? Or maybe jump if you have ever touched shaders. Okay. So we have some people who already know what it is about, but it will be really interesting because we all have also total beginners, which is great because I've prepared this presentation to be accessible for all, and having a lot of different stuff and more focus on the creative process of shader rather than really being fully technical. Okay. So let's start with a summary. So I divided this presentation in 3 parts. The first one will be a sort of definitions part in which we will see the different fundamentals of core shaders. Also, what is a core shader? And there is a part of the title which is the unsupported feature of unlocking the VFX world. So what are VFX exactly? We are going to try to define what is this presentation about in this. In the second part, we are going to see what is the creative process behind creating shaders. And the third part will be a sort of global conclusion explaining the different elements of core shaders, and also taking a step back to be able to really see the limitation, and also talk about future of shaders, because that's something which is really moving, especially focusing on the unsupported part of the title of this presentation. Right, so let's begin. What is a shader? A really interesting question. Wikipedia says a shader is a computer program that calculates the appropriate level of light, darkness, and color during the rendering of a 3D scene. That's actually a pretty good definition, but that I would define as really inaccurate. And I will say that because this definition is great, like it's great for beginners, but it's actually really limited in terms of what shaders are capable of. And so I would replace this definition by instead, a shader is a computer program that calculates any render time logic during the rendering of an image. The difference between what Wikipedia suggests and this one is that a shader is just, generally speaking, a program which intervenes during the render to modify the result of an image. So a shader can be really basic things like just taking the texture from a skin and applying it to a mesh, so to a 3D model. That's the most basic shader, but we can do also more crazy things with that. And that's on this basis that we can create this presentation. So on this slide, it's a really, really good illustration coming from the learnopengl.com website, which is really, really good to learn shaders. And they have really good illustrations too, talking about the different elements. If you want to restart shaders, that's one of the websites I would definitely recommend you to read. Like they have multiple articles which are really interesting. And here, this graph represents what we call the rendering pipeline. Basically, the rendering pipeline is the whole process of rendering a single image. And during this whole process, we have different elements and different shaders which can execute. Because shader, as I told, is a general term for defining what the GPU program is. And there is actually three types of shaders. There is the vertex shaders, the geometry shader, and the fragment shader. And during the rendering pipeline, we try to assemble the different models and textures to convert them into a fully rendered image that you can see on screen. So for that, the process is pretty basic. The GPU will take, in first place, the different vertices that you have in your model, and it places the points in 3D space. Then it will create the geometry shader, in which you will create the different faces between each point. Once done, there is a process called rasterization, which will convert your different faces into pixels, or fragments to be exact. And each fragment, for each pixel of the fragment, you more basically like just writing different things onto each pixel based on the different parameters that you have in. And at the end, you have test embedding, which is superposition of the layers that you rendered into your different fragments. So that's a really general introduction to shaders and what shaders actually do. But in Minecraft, they act quite differently. Are really relying on this geometry shader. That's why it's so hard to have. That's one of the reasons why it's so hard to see really modded shader, how we call them, into vanilla Minecraft. But we have access to two shaders. We have access to the vertex shader, which computes things for each point. And we have access to the fragment shader, which computes things for each pixel of each fragment. And nowadays, we have access to 56 different core shaders. That's great because I talked about what are shaders and how they act in Minecraft. But in Minecraft, they act as core shaders. Core shaders are rendering the different parts of your game. And each of them control a different things. So basically, entities are grouped into a single core shaders, or blocks are rendered into a single core shader. What does that mean? It means that you can provide code only for one type of things at the time. So for example, you can apply the shader to all blocks, and it will apply the shader to all blocks of the world. Unless you select them. Okay, we can going a bit too fast compared to the slides. But here we have the example of render type entity translucent, which is one type of core shader. So for this core shader, you have the vertex shader and you have the fragment shader, which works together to render the image. And as you can see, this image comes from the Vanilla Shaders wiki. And it illustrates well that, so basically it's just a texture painted in red in the fragment shader of the render type entity translucent. And you can see what it affects in game. So it affects all the piglins, it also affects the players, and it affects the different parts of the horses, like custom parts of the horses. And here you have like an exhaustive list of what this shader specifically affects in game. So I know that if I want to edit like player skin, I will have to touch the render type entity translucent core shader. So we can go on this example. So this is a picture of me a few days ago on this just on the seats there, and I use the software which permits me to see the different step of the rendering. I'm not going to go really deep into how the program works, but it notably permits me to see the different steps of the rendering. And so I can see the mesh of my skin appearing here. This is really important because this mesh for each edge, like not edge, but for each vertex of the mesh will be run the core shader, the vertex shader of the render type entity translucent. And the vertex shader will pass informations about what part of the texture it should apply to this part of each part of the mesh. And in the fragment shader, it will apply the texture to the actual mesh, like this. So it will bend different textures. So it will pick colors on the texture, and it will also pick colors on the light map. And so it will basically hook the texture to render fragments. I see Curious asking in the chat, why is the skin upside down? This is a great question. The skin is upside down because Minecraft has flipped down the axis in the the y-axis is flipped down. That's a sort of convention. It may change depending on what shaders you are using, but in Minecraft, it's the y-axis is pointing down. And then, so we have this rendered image, and it will paste it on top of the other one based on the depth of the rendered fragment. So you can see that it's rendered another image. And so what is possible with core shaders? because it was like, I know it was a really technical introduction to what core shaders are, and I'm sorry about it, but it's also important. But what can you do with core shaders? That's the interesting part. And I think a lot of people here are here to hear about that. So from a technical point of view, you can read some hard-coded data that you can add to your shaders or in the texture. You can read variables, which are like the game time, which is variables which are for the whole world. And you can also read data, live data, that you can modify, for example, with a data pack. And you can read, for example, the tint color. So you can affect laser horse armors, potions, with the snapshots. You can also affect basically all items, I think. I'm not very sure. I did not really check the latest snapshot, but from what I've read, like it might be possible to modify any item, which is really, really powerful, like to tint any item. And you can also manipulate things in the rendering process. For example, you can change the behavior of how vertices are positioned, or you can manipulate the rendered pixel colors. What does that mean? So modifying vertices positions could mean that I can scale players by absolutely by two. Like for example, like the attribute generic scale was something possible with shaders before. Really hard to do, but that might have been possible too. And manipulate the render pixel colors means that you can also change the color. So basically, it's really easy to apply a whole filter on your whole screen. It's possible like to render everything in black and white really easily without changing textures. And the interesting part is when you start mixing the different elements, because if you are able to bake at the same time live data with hard-coded data and modify your content based on live data or moving data like time, then you can start animating things. And that's where you have the most powerful parts, I think, from core shaders, that you are able to animate things and basically break the 20 hertz animation frame rate from which you are limited by the vanilla 20 TPS. With shaders, you can animate things at like basically update everything at each frame the client will render. That's a huge part, and also it removes a lot of stress to your server because everything is client side, which is a huge thing too. Right. No, let's talk about VFX. So, what VFX are deserving? First, VFX means visual effects. So people often talking about like VFX, really short animations, but VFX are more than that. They are basically anything which relates to visuals and player experience. So VFX deserves realism and or fantasy, which means that you can mix the two together. But in the idea, you are trying to improve your visuals with VFX. And indirectly or directly speaking, you are deserving immersion, atmosphere, and feedback. So it includes a lot of things. So I included some examples of where it can be used. There are things that are vanilla supported, but you can always enhance them, like particles. There is character-based effects, like for example, skin animations or stuff like that. There is damages and destructions. That's something we really rarely see on Minecraft, but like there is some mods creating like 3D particles effect when you break blocks or stuff like that. That could be something possible with Cursor Shader. UI and feedback. There is really interesting takes about animating UIs and creating stuff with just shaders in UI, especially that you can, as I told you, you have access to a time varying variable, which means that you can animate things in UIs without using any commands or anything. You can, SFX. SFX is really interesting because SFX is what people are actually encoding VFX generally. SFX are just small effects. So, for example, if I jump, I will have a small effect around my feet to say that I jumped higher. And it also deserves, as I was saying on the previous slide, immersion feedback. If you have an effect around you when you jump, players will directly know that they can jump. They are actually jumping higher. Cinematics, we'll skip a bit about these ones. Simulation, so everything which is physics based. I haven't seen that. That's something possible. Post processing. That's what this post processing shaders. That's something which is actually supported in vanilla. So I really encourage like that could be a great thing to look for them. Like post processing effects are really cool in vanilla. A bit limited right now, but we can hope better for the future. But we won't talk about them today because too much things. Like it's another panel of it will need another panel just to talk about that. And environmental, so basically particles and giving an immersion for the player. All right. After this introduction, we can talk about real shaders. Here, what I wanted to do with this part was both to create, to give you the whole process of making shaders. So we have a study case onto a Skybox. We will enter a bit into the details of the technical working. It works in the background, but we aren't going too deep neither. It's just to give you a quick look about how it works. So why a Skybox? Well, I took a long time preparing this panel. Originally, it wasn't so supposed to be a Skybox, but Skyboxes are a really, really efficient way to give immersion to the players. Here are some different Skyboxes I've done in the past because they are really, really efficient in terms of time invested for the immersion you will give out to the players. And immersion is something I think is missing a lot to currently to the different like to the whole map making area. Like immersion is what makes your players go from, oh, this map has fun gameplay to I got an incredible experience on this map. And skyboxes are really important in this sense because you can go from the vanilla sky to a whole global experience, which is totally different. And there is different levels. For example, on the bottom left one, like the greenish sky here, it's only the sky color which edited, and like just changing the fog color can change the whole experience of the player. Today we are going to go on a technical one, so you have some examples of what is possible too. I don't wanted to just change the fog color. There is more interesting than that. That's why in the creative process starts with starting with inspirations. And it is really, really important to define your objectives before starting creating shaders, because most of shaders are basically using math as a tool. That's really different than using math, like in class, for those who are still in or at the uni. That's totally different. Here you are using math art tools to create and enhance your creative process. And when you start defining your inspirations, that's like when you are trying to define a global theme for a map. Artists going to create a global experience with their models and their textures, start to get their inspirations. And for that, I defined this quick mood board with two main inspirations, which are Outer Wilds, which is a space exploration game, which is really great, and The Night Sky from Animal Crossing, which is a really calm game. And Aurora Borealis, which is something I discovered recently in real life, which is really impressive. And I really wanted to create a night sky, which is really calm, and to create a chill experience for the player. So from these inspirations, I started. Okay, so let's start the watch. I started a quick setup. To be fair with you, I put it behind me, like on the different slides, approximations of the actual implementations. I didn't wanted to make it overwhelming, but I still want some people here who may want to learn more about shaders be able to just read the stuff. And it may help in the understanding, but don't care too much attention to the actual working. That's something you can learn later, and I will more focus on to what is the creative process and the different steps, and how I got from nothing to the final result you will see. So quick talk about the vertex shader on the left. I'm just identifying, because I thought if you apply a vertex shader, a shader by default, you are modifying the whole core shader, which basically means that you have to you will modify like every blocks, and we don't want that. Usually we use item, so you don't want to modify all items in the game. So that's something which is important, and so you have to exclude the case. That's why there is an if-else condition. And on the fragment shader, I'm just parsing the data to get the time and the system. And from that, I will now hide the actual vanilla Skybox. And we are now right now inside a full box, like it's just a big item, and scaled up with an item display, which is all around us. And with just this code, it permits me to go on this one, which is just a Cartesian coordinate system. It makes me it permits me to talk about something really important about shaders, which is that you don't have, like in regular code, you don't have a console to output you like your debug errors or stuff. So the debug is only visual, like it's exclusively visual. And so we really often use colors to debug things. So for example, here you have to consider the red, blue, and green channel, the green and blue channels. And so your Z coordinate becomes colors. And that's why it's a really nice hue, because everything looks really smooth. But unfortunately, you cannot really see it correctly. But behind you there, you should see black because our coordinate system is between -1 and 1, and colors are displayed below between 0 and 1. So for that, we can just make sure that our coordinate system is comprised between the two values. You can also do that. And so basically we are into this sphere here. We are basically into this sphere here. This sphere represents the huge sphere in which we are. And the second step I've done here on the Skybox is that I placed everything between 0 and 1. So you divide it by 2. So it's between -0.5 and 0.5, and you do plus 0.5. So it's between 0 and 1. That's for the technical part. With these coordinate systems, you can create any other coordinate system. So you can go an angular coordinate system. Let me grab it, like this one. And for example, here it's angular, which means that it's like your camera rotation in Minecraft. You have a up down, which is the pitch, and you have the yaw, which is left and right, which is important for some of the skybox. Like most of skyboxes on the internet that you can find for free are huge textures encoded in this system. And so you just have to apply the texture then onto that. So for example, I've applied in one here, and you see you have a custom skybox now, just applying a texture onto the coordinate system. And I want to do a quick stop on this, like on this sky here, because it permits me to talk really briefly about color theory. And you can see that just changing the color of the sky, like putting a nice sun in the sky, just mess up with your brain at a point where everything looks being the day. But if you actually look at the ground, you still have the night shading, which is really important. That there is a lot of stuff which are just controlled by how your brain interprets stuff. So basically, if your brain thinks it's the day, like everything will be smoothly looking like being the day. And that's where was my point, mainly about at which point using the skybox is important. Okay, we may move on to wait, don't want to skip any slide. So let's okay. That was I just missed the slide. Here, that's a really basic representation of the coordinate system. It looks really weird from the inside, but I've included here a quick drawing about how it should look like from the top. Like if you are below it, you can watch perfectly aligned to it. Like you will see those lines appearing. And that's why it's important. That's the only thing which is important. Your coordinate system is always conserved. Despite if you are inside the whole ball, like you will just see the different lines appearing. Well, I started with that just to show you at which point the coordinate system is important to create visual effects. And what are we trying to achieve right now? Right now, the most important is just to create a basic sky grid, like just a grid of stars which will appear above us, because that's a nice objective to begin with. So the easy version of it is to start with creating a grid. So I just took the coordinate system and I divided it by the Y level. And if you watch above your face, you will see the perfect grid appearing. Yeah, I see comments about mip mapping. That's something we can fix because on Earth you won't see infinite sky. So we just want to add a nice gradient. And with that, we just have a ceiling above us, and that's perfect. But same, Earth is round, and you have to be like stars are bending above you. So you can also add a small bending, just like that. Here I added a bending, just creating a curve. And I also added a pretty important line, which is permitting the whole Skybox to rotate based on the game time. So in one day, it will do whole turn. And here we have a grid. So we could basically create a dot inside of each grid, each cell of the grid. But that's a bit too regular. I mean, if you just place dots in the sky, it's not very interesting for your use. So we want some randomness for each of them. So for this randomness, we can just take a random noise function. If I remember correctly, I just took the one from the Book of Shaders, really great reference. I will link everything later. But then it is, let me check. It might be 393. Oops, no, it's not. Okay. And so I added a randomness for each cell. And so here you can see that each cell is more or less filled by the different, like it just represents the values. And then we can scale that correctly now. We can just scale that correctly and place dots instead. And you have it with smaller dots, but it looks very grid, like it's just a grid with dots in them. So you want to add variations. That's a, oops. Oh yeah, okay. You want to add variation and create offsets. I won't talk about code anymore because it's not very relevant for this presentation to talk more about code. But we will focus on the sky. Don't hesitate to use your spy glasses to watch the sky. Because we'll do huge steps between each step now, so we can go a bit quicker. So we want to add a custom offset for each of the star. So we get that. I also scaled down each stars here to be able to have a nicer render. But you can see that there is some stars which was missing, or some of the stars which are just weirdly cut, like it's not dots. And for that, we can see that in displaying the actual grid. And you can see that there is actual grid, like actual cells of the grid, which are totally empty. And that's because we just offsetted too much the stars, and that the stars are finishing in a cell like outside of them. So we can quickly fix that with computing the result of the next, like the adjacent cells. And now it's fixed. So you have in some cells you have 0 stars, and on the adjacent cells you have multiple stars. We can remove this effect. And here we have already a pretty nice sky. We are pretty close from the reference images that I sent to earlier. Like in terms of close to Outer Worlds, but that's not very like we can do better. And for that, like, I will do a huge step now, but we want more variations. And in the sky, if you watch closely at a full night sky outside, you will see that each star is quite different. And like each star has a different glowing value, and each star has a different color too. So that's something we can add. Oops, I have to change that. And so on this one, I just added glowing to each star. I also changed, oh no, not right now. I added glowing to each star, and I added a custom color. And important thing about pictures and the experience you can create, if you have the possibility of using physics-based stuff, it will look better than just custom stuff. Here, the colors of the stars are based on randomness, indeed, but the randomness doesn't select a random color. It selects a random temperature, and then it uses an real life equation that we use to compute the temperature of the sky of a star based on the color of the star. And here it's just the reverse process. So it looks nice because like it make look nice because you are trying to imitate the reality. But on that, it still is very black, like not very realistic. And that's when I just watch some sky on videos on YouTube on just night skies. And it's very rare that the sky is totally black because you have the atmosphere and all stuff. You can go into realistic stuff and create your own atmosphere and stuff. Like I've seen that in Minecraft before, and that's really cool. That's really intensive for the computers. So we might choose another option, which is just changing the backgrounds and changing the different parameters we already have at our disposal. So we are now with this setup with a bright sky, because like it's important to note that stars are emitting light, so your sky is not totally black, and you also have the atmosphere. And then that's cool, but a night sky has way more stars. So that's when I decided to add a second layer of stars, smaller ones with less effects, and so it just way cleaner, you know. The idea is that the player can just use their spyglass and watch the sky closely and discover new details. In this iteration, it's also interesting to note that I changed the render of the star from dots to squares because I want to respect Minecraft style when I create stuff. Like it's really more interesting visually when you have something which looks Minecrafty, even if you involve more in real life stuff. That's always good to respect Minecraft style to get better results. So yeah, here it became do I have something there? I don't remember. Oh no, I have nothing. Sorry. And there is a last step that I won't take too much time to talk about it. But I talked about the inspirations with Aurora Borealis. So I basically added them, but that's quite laggy. So if you have a bad computer, just watch down, watch down, because I didn't got the time to optimize them. And I didn't show that in MCC actually, but that's full new stuff. But yeah, and it permits me to also show another point. I will remove the Aurora Borealis. But it permits me to get another point. Unlike data packs, shaders are running directly, like it's real code running onto the computer. and that's important because you have to take it into account. If you are developing onto a good machine with a good graphic card, you have to take into account the compatibility between the cards. You also have to take into account the lag it creates to run those programs. Like, for example, if you have a really good computer, like, you might see some FPS dropping. Like, sometimes there is things which might make you which might make your FPS drop down of like 2 or 3 FPS. But for an end user who has a potato PC, it will be half of the FPS. So you have to be really careful, and sometime also take into account, like, maybe suggest into the settings of your map or your data packs just to activate or deactivate visual things. Yeah, so how to improve? I had another slide on that. Yeah. Which is, I basically gone over that, like getting closer to real life physics. Really important. But also getting closer to the Minecraft side important, visually speaking. And the last part is adding more diversity. If you have a pattern which is repetitive, it will be not that what you will make will be boring, but it will be less interesting for your players. Like, for example, for the sky, during the whole process, it was important to have in mind, okay, I want the players to be able to take a spyglass and just watch at the sky and be able to discover some things in the sky, like just watch it during a few minutes and discover new things. Limitations. I'm going to try to accelerate a bit because it has already been 45 minutes, and we still have a whole section, so I will accelerate a bit. But limitations, Minecraft has a very, very basic rendering pipeline. You are limited by what core shaders are offering, and interaction between clients and server are very limited. The only input you have currently are fog color and the tint index from laser or armors, which is very limiting to pass data into the shader. Right. Step back and conclusion. I think this part may be the most important one because right now you've seen different things, like a small introduction to how shader works and what could be one of the creative process available for making shaders. But this one is more an overall introductions to different stuff. One important thing is sodium compatibility. That's a very common question and commonly misunderstood too. Sodium is changing the rendering pipeline for blocks, only for blocks, at least currently. I know they have plans to change that later in the future, but currently only for blocks. The only core shaders out of the 56 mentioned, there is only those which doesn't work. Plus the includes light.glsl and fog.glsl. So if you try to modify the fog, it won't work for everything. And you can check by yourself into the future. They have a feature which prevents you to upload a pack. You can check directly this link. I will link it into the presentation, into the channel of the presentation later. But this link is directly pointing to the source code, and it's literally this list. But very misunderstood. If you are modifying things to items, for any sodium clients, and you don't touch to the lightning or the fog, it will work for everyone. Sodium compatibility isn't that bad, even if they don't want to retouch to core shaders. That's very sad. Like, they don't want to expose any information about sodium. Like, we asked a while back ago about just exposing the information into shaders that the user is using sodium, so you can have a different behavior, but they declined the feature request. So in the future, we don't have to expect that much about sodium developers. They also want to change the rendering pipeline, rendering pipeline for items to the future. So yeah, that's not very promising on their end. But right now, it is working. It has been working for a few years now, and it will continue working probably for a few years too. in the unsupported part of shaders. Mojang stated in like 3 years ago already that core shaders weren't officially supported. And recently, very recently, in 24W34A, they quietly changed their discourse, which was previously, for now, it's not supported. No, it's sure that it's not supported and it won't be supported. There is some reasons, I think, to that, mainly because core shaders may change very often with updates. Like sometimes they just change what informations are exposed into the shaders, and I think it's more an issue of not wanting to provide consistency. Like for data packs, if something breaks, you have a new option, like a new way to do it in few snapshots after something breaks. That's not something you will see with shaders. If they want to break something with which were working previously in shader, they will do it. I think it's in this way. That doesn't mean that it's not working or they plan to break them. Like until they completely revamp the rendering pipeline, that's not something which is going to happen. They also stated into 24W34A that they want to provide alternatives to shaders, and we've already seen some of them. Like I didn't thought a second that it would happen so fast. So we've seen new custom model data, custom tooltips, emissive textures, camera overlays, a lot of stuff. But that comes like replacing is a big word for me because all those new features also add new possibilities for shaders. Like it's literally we try to replace shaders, but no, we have more stuff to create. Like we have new toys to play with. Yeah. And it brings me to this slide. That's actually one of the last one. So no worries, I won't go over time. But it's a bright future for shaders. Actually, it's not because it's not supported that we are not able to see some solutions in the future. Like we can imagine with the new custom model data and having everything custom data drive to see the possibility to have a shader API or something like that, which would permit to input our own shaders into the pipeline, not or stuff like that. For me, there is no reason to be really worried right now about shaders, how it's going to be into the future. It can only go better into the future, to be honest. We can be really happy already that Mojang didn't just nuke core shaders. They could do, but they don't do it. And bright future for it. And it's your turn. Some of the links I will share with you all, same into the shader, like under the shader panel thread on the Discord. I will share all the links, but there is a lot of great links to get started. It's a whole category of Minecraft mapmaking which is not very well documented, but there is a reason. It's that main of the things you want to do with core shaders are mainly trait and see. So don't hesitate shaders from other people's. Even the shader of this presentation, actually, I will put it at your. Don't hesitate to break up stuff, like just trying to see what's inside it. So yeah. I think that was the best advice of this whole panel. Try it yourself and see. But all right, thank you for listening. I hope you've learned something. We have really little time left for the questions. I'm sorry. I thought we would go a bit quicker, but
thanks, Neylz, for the shaders panel, and we'll do a couple questions here. But I think everybody really enjoyed this night sky. I don't think people would even mind if this night sky was just on for the rest of the summit. But yeah, we can take some questions. I might just read them off to keep it simple. We have some questions about community for core shaders, like where our core shader are just found and people figure stuff out. Is it MCC? Like where is the community?
I might say that there is a community, but we are very few people. Don't hesitate to jump in. Like there is the how is it called? The Labs, which is a modded server, but there is a Vanilla shaders there, a Vanilla shaders channel there, where you can exchange stuff. Also on MCC, I think there is always people who are happy to answer questions about shaders. There is a community, but we are very few people right now. So I hope
Then I'm getting some
we'll see
questions.
more people soon.
How do core shaders differ from actual shaders like Iris? Like
So that was
complementary.
some. That's a good question. You have less control onto the different stuff, but you also have more control on other stuff. Maybe not. Maybe I shouldn't say it like that. But core shaders is something like you can have any vanilla client, even sodium clients, if you do your things well. That's the big difference is that you have access only to the vanilla rendering pipeline, while when you have modded shaders, it's replaced by a custom one, so more complex one.
Cool. I'm also getting a question, where can the core shader resource packs be found from other people or maybe some of the resource packs in this presentation? Where is the main place to find these shader packs? Vanilla shader packs.
In the Vanilla Shaders wiki, you might be able to. There is a section for example packs. There are few people I really recommend you following on GitHub, which are Bradley Q and probably MCTS. TS has also one one repo with a lot of shaders in there, where it's really great to learn stuff. Just open a project and also sometimes you can just control F into Minecraft Commons project channels and you will find a lot of stuff like Goldmine.
Cool. We have a specific question about communicating fragment shader information to the vertex shader. Is that possible?
No, it's not possible because fragments are run after the vertex shader, but you can do the inverse. Like it's supported natively by OpenGL, that you can pass data from your vertex shader, so point by point, to pixel by pixel.
Cool.
I see
Getting a
uniforms. Uniforms are different. Uniforms are like constants for a shader, while um, how is it called? You can pass data really that you create. Like you can even create your own variables in a shader, while a uniform has to be created before the initialization of your pipeline.
I see. I know a couple people are very curious about learning how to write GLSL. I know there's like the shader book and stuff like that, but curious specifically is asking, are there other coding languages you might benefit if you learn that and then learn GLSL,
Definitely,
or is it just like
definitely.
jump into a shader book or whatever?
If you learn GLSL, I think you will become a competent. No, not like that. But if you have learned, it's more the other way around. If you have learned C, it will be really easy for you to do GLSL or C++. It will be really easy to do GLSL for you. On the other way, if you learn shaders, it will be easier to learn C, but there will be more stuff that you will have to learn for completely being able to be fluent in C, you know.
Yeah, I would make the claim that GLSL can be simpler than C because once you understand how it interacts with the shader itself, it's a very simple programming language from a syntax and
Oh,
from what you can
yeah,
do.
definitely. GLSL is easier than C. Um, mainly because you don't have access to pointers. But
I have an interesting question. I know there's sort of like two parts of the shader world. There's people using shaders to augment gameplay features, like we used emissiveness for adding emissiveness to like some of the summit features. I know Object
yeah.
MC, this animated skin, fancy pants, all those sort of things are just there to augment vanilla features. Versus there's a whole other segment of people doing really crazy stuff like oh no shader worlds, and a lot of people are doing tech demos with shaders. Um, on that first leg of people extending gameplay features, do you think there's an opportunity for compatibility between shader projects from the outside, like being able to take a set of shader changes and make them compatible with each other, like through a program like Weld?
Mm, I already had some ideas about that. Like, it might be even better now that no, it doesn't really change that much. But in 1.21.2, they namespaced every shaders. Like before, it wasn't namespaced. Now it is. So it means that there is less change of overlapping different packs, and it could be possible, but you would need an external tool, like before for custom model data.
Right.
And it also requires an infrastructure to be able to, like for each shader, really show, like you would have into the vanilla shader script to mention where you can implement your different libraries. Because there is shaders which like it's really hard to stack different shaders. Because sometimes you can like, so you have access to 24 bits with thin color, for example. And if I need 24 bits for a map or for a tool, I will use 24 bits. But maybe there is another tool which is going to use also 24 bits, or who is going to use the alpha channel of the texture, and another tool will also use the alpha channel. So yeah, it's hard to create conventions about that.
It's definitely been in the talks with in Smith and Weld to get some sort of partial support for specific shader situations with Weld, but it's very difficult, especially nobody on the team is very familiar with shaders, but
Yeah,
it's been requested.
that has been, I guess so, but it's really hard to do it properly
Yeah,
without overlapping.
cool. Well, we hit the 30. I don't see any lingering questions if there's any last question, but I think it might be a good time to close the panel. So I'd like to thank Neylz for doing a panel about shaders. I think it was a very immersive experience for people on the server. And if you weren't able to see the shaders, the stream was available as well alongside the VOD. Thanks to the audience for joining us. I know for some people, especially on the West Coast, it's like super early in America. So I appreciate the audience coming on and joining for our shader panel. Super, super fun and very very informational. If you want to learn more about Neylz's work, including all of their links, you can check out their forum post in the Boots and Panels forum. I think they'll list some of their getting started links on the
Yeah,
last slide.
I will add later today all the links you've seen into the presentation, and I will follow up even later with more packs and information.
For sure, we'll keep an eye out. Coming up next in Summit is the Beat panel, which will be happening, I think, in 3 hours. 11, 12, 1. Yeah, 3 hours. 2.5. So we'll have the beat panel coming up, and then after the beat panel, we have closing ceremony. So I would recommend sticking around on Summit to try to 100% all the plushies and stuff. But other than that, we'll see you soon at the beat panel.
See
Thanks
you.
everyone for joining.
Yeah, thanks everyone.